Hello, welcome back. We're looking at part B of this horrible moments question here. We've found X in part 1. So, part B changes the system. We've got a rock now placed at B and the plank is on the point of tilting about D, and we want to find the weight of the rock. So I guess what that means is, although we've still got our two pivots, we've still got our beam sitting on top of them, what's happening is that a weight is being placed at B at this end, and of course if that is only a small weight, nothing much will happen. But the point of tilting is when that becomes so heavy that actually it begins to lift off. You can see if I make it really heavy, this weight, the beam actually lifts completely off one of its supports. So that would be a tipping event. We don't have to measure tipping events at A level about how much that's, what's happening in terms of the movement. But on the point of tipping means that, can you see it's just wobbling and trying to lift off of that other pen? And in fact, if I were to move that pen out of the way, it wouldn't bother the system at all. So basically, I move that out of the way. It's not easy with one hand. There we go. Then what would happen is the plank would stay exactly where it was. So that second support in a point of tipping example is actually not providing any support for the system. The rock at this end is enough to balance out the fact that the centre of gravity is the other side of the pivot. So try that on your own. It's just the right amount of weight downwards, or the right amount of force downwards from my finger is enough to balance that out. If that's too little, then it needs the second support. If it's too much, flies off the support. But if it's just on the point of tipping, it doesn't really need the support, but we haven't taken the support away. So what does that mean in terms of our beam? So what it means is, and I've redrawn my diagram, some stuff has changed. Now, the weight is still the same for the beam. That's still acting right in the middle of the beam. The distances between the pivots haven't changed. I've put in my X that I found in the first part of the question. So none of the distances have changed. The only thing that's changed is, well, the only thing that we can see that's changed is this rock has been placed on the very end of the plank at B. So obviously this is providing its weight, is what my finger was doing in the experiment. So that's pushing downwards there. And they don't tell us the weight of the rock. That's in fact what we want to find. So the system is on the point of tipping. There's a little phrase to look out for, on the point of tipping. And we are trying to find the weight of the rock, the force that it's providing at B. So that's what we're trying to find. So we don't know this, call it W, because that's always going to be helpful when we're working it out. It's going to be W newtons. And the other thing that's changed in this system is the reactions. Now you remember when I looked at the ruler, all of the weight or all of the support was here at D, at this pivot here. So I removed completely this pivot here. It didn't really need it when it's on the point of moving. We're in that delicate balance. So that tells you something about the forces going on here. Crucially, this one is taking the whole weight. It's all balanced on that pivot. The left-hand pivot, when I looked at the ruler, not on it at all. get out of the way. So I can go ahead. This is 0 newtons up here. 0, nada, nothing. I don't know, my screen has frozen. Hopefully it'll catch up. And the forces at D, well, that's now quite a big reaction. And that is going to balance out the weight of the plank and of the weight at B, the rock. So I'm going to move to a new video.